What's up, everyone? Welcome to my April 2021 troubleshooting and optimization guide. I know there are a ton of guides out there of other YouTubers doing this kind of thing, but we're all different, and I'm just going to give you a bit of background history on myself. And this is the process that I would go through if someone, a friend, a client came to me and said, "Hey, fix this. It's running slow or whatever." And this also applies if you've bought a new system, a second-hand system, or you've just built your first system and you don't know where to start. Then this guide has a lot of useful information. And it's just an accumulation of all the years I've spent building and troubleshooting because I never went to a PC tech, back in the year 2005. So if you already have a good idea of what you're doing and you know some of these headings here, as you can see on the left, I'm going to timestamp all this. Just click ahead. Don't listen to everything and then complain in the comments that I talk too much, because the whole purpose of this guide is to teach people how to troubleshoot their own problems. So when it comes to Windows troubleshooting, especially gaming frame rates and FPS, it is a process of elimination, and all you can do to help streamline that process is base your troubleshooting on the symptoms. So for certain symptoms, you might skip to a different type of troubleshooting. You'd know where to start. So if your games are just crashing, you'd naturally think to check the stability. It would be a stability issue. If your games are stuttering and lagging, background processes would just be the natural assumption, but it could also be a stability issue. So as you can see, you have to check all of it. You can't just go, well, nothing's wrong. I checked background processes. Nothing's running in the background, so there's nothing wrong with my system. There could be a minor instability that's not crashing anything, but it's causing your games to stutter. So that's just to give you an idea. And the other thing it could be is if you've looked up, maybe you've got a system you've had for a while and you just upgraded the graphics card. There could be multiple issues that would cause low performance. You could have wired the power supply incorrectly. There could be one Y-splitter PCIe power cable instead of two on a higher-end graphics card. The PSU could be inadequate. It could be so old that even though it's a bronze, 650 watt, which is more than enough, it could be so old that it's not providing adequate load power. It's not handling spikes in power consumption properly. Or something could just simply be faulty out of the box, and you'd get to the bottom of that eventually once going through the troubleshooting steps. And one more thing is, if you've bought a new GPU and it is advertised, or you've seen benchmarks and the benchmarks show an X game, it's getting 100 FPS. Whatever site you use to check those benchmarks, you have to check the test spec, the test bench, test system. So just as an example, I'll look up the RTX 3070. Hardware Unboxed is a really good site, and they actually have an offshoot called TechSpot, which has the text, the text articles for it, and you can find a review with benchmarks, right? And most people will just skip to the benchmarks. A lot of people, not everyone. I know plenty of you are smart enough to check every little thing, but you have to make sure that you're looking at what kind of CPU and what kind of RAM they're running in the test system, because if they're running a top-end CPU and you're running a mid-range CPU, even though it's a GPU-bound setting, you'll still end up with differences in performance and especially minimum FPS. So you have to make sure they're not running like a 5950X, for example, because the majority of users are not running such high-end CPUs. We're mostly running Ryzen 5s, even second and first gen, and i5s or i3s. Hardly anyone, like only the extreme enthusiast community, runs the top-end CPUs because they're just so expensive and they're not really fit for the task. They're fit for the task, sorry, but they're not ideal. Like, it's not always worth it to spend that much money unless you're going fully high end. So sometimes a GPU upgrade is what everyone recommends, and they say, that's going to be more important than the CPU, but it all matters. Like, it all comes together. So if you've got one weak point, if the RAM is a little bit higher latency because the low latency kit was an extra two times the price, that can be the difference in why your game's running 30 FPS lower. Literally, running high latency can cause that much of an FPS difference, or running a single stick of RAM because you thought that 8 gigs enough and they didn't tell you dual channel is important. So things like that. So other than that, hopefully the advanced users have skipped ahead by now, but I'm going to start here at the top. You can see the descriptions that I've written down, and this is just for me to keep track of what I'm going over, because I do tend to go off on tangents that aren't important. I over-explain things. So anyway, first off, startup optimization and background apps. So when you first install all your applications on your PC, you might have friends that are already PC gamers. They tell you, grab Discord, grab Skype, and you're just like a beginner, right? You're installing all these apps, and your friends aren't telling you the things that they already know, which is make sure you disable it in startup apps if you're not going to use it every time you turn the PC on. Or make sure you show your notification tray. If you right click here, go to taskbar settings, and go to notification area, select which icons appear in the taskbar. Now this is important because by default they're all hidden. And a new user that installs apps and is not that tech savvy and just learning, learning all this stuff, does not naturally think to click here and make sure these apps aren't running, because they are. Like, they don't even know that they're running. They might even assume that it's an icon as a shortcut, when it really, these are notification icons for the running applications. So if the app's not running, there won't be an icon for it in the taskbar. So the easy way is to just show all icons. That way you don't have hidden stuff running. And if you've got like Skype, Discord, things like that, you're done with them, right click and close them when you're done. Depending on the strength of your system. Higher end systems with tons of RAM can usually keep plenty of tray apps running, background processes, but it's better to just keep it as minimal as possible, just to avoid that clutter and CPU usage spikes. Even on a top end CPU, a background process doing too many things can end up affecting the performance. Even RGB software can cause FPS drops. So you can Google that. You can look up like NZXT CAM software was causing problems at one point. Razer Cortex software has caused problems. So there's all these little things where if you keep it minimal, you're minimizing the risk of running into one of these issues. So then you want to look at the Startup tab, press Control-Alt-Delete, go to Task Manager, and under Startup, you only need the bare bones applications running. So Realtek is usually motherboard audio. Most motherboards run Realtek audio. And then your Windows security is Windows Defender. If you're running like some premium antivirus, feel free to use that. It can cause issues. Most of the antivirus related issues are not from Windows 10's built-in antivirus. It's from using overly aggressive aftermarket antiviruses. So if you know safe practice when it comes to opening emails and checking the URLs and things like that, Windows Defender is fine. If you kind of don't know what you're doing, just don't open emails unless you're sure you're the one that solicited them. So if you get an email from, let's just say Amazon, and it's in your inbox and the title is like, your Amazon package is delayed and you never ordered an Amazon package, that's a phishing scam. And when you click those links, you'll end up with malware or a virus or something like that. So basically, it's something you have to learn over time, but be careful with links and be careful with installing random applications, especially like hacking programs, for example. Some people will try to hack in games or run trainers in a game, and when you Google for that trainer, like it might just be a simple trainer that gives you God mode in an offline game, in a single player title, and it comes from some random website, and there's no user feedback, it's not a well-known website, your friends don't know about it, or if you're not sure it's a legitimate source and you've never downloaded them before, you're best off just avoiding that. But if you're like on a forum for Steam, for example, if you're on a Steam forum through the Steam application, gaming application, and you see tons of people have downloaded it, then your chances of that trainer being safe are much higher, because many people have tried it and no one said, hey, I downloaded this and ended up with a Trojan or something. So that's some safe practice advice. But mainly you just need to know to disable anything in here that you don't need. It'll affect your startup time, and it'll also affect how many background processes are running. So as you can see, I've had some of this stuff installed that I didn't want, and I just disabled it. Right click and disable. And yeah, that's it when it comes to that. We've done notification tray, and yeah, that was it. And then we'll go to diagnostic apps. Now, if you know what apps to use for which purpose, like as you can see here, I've given a rough description of what they all do. If you have your own apps, just use them. I'm not going to tell people which, my choices are better than yours, but I will just go over them. 7-zip for unpacking zip files, same as WinRAR and WinZip, but I find it is a lot smaller footprint and streamlined. The UI is just very simplified and it works fast. So that's why I use it. CPU-Z is just good to have for checking your motherboard model, for checking your BIOS version, for checking your RAM configuration. It's just, I would recommend this for anyone that really wants to troubleshoot their own problems. If you don't, then you shouldn't be watching this guide. But I would download all of these because I'm going to be referencing them throughout the guide, especially in the troubleshooting section. So if you are troubleshooting, just grab all these apps if you know how to download them and you don't have any problem. If you don't know how to download them properly, I'm going to go over that because, believe it or not, I've had new users that are gamers ask me for help, and I've recommended the apps, and they haven't even known where to click to download the apps, even though you can search it in Google. And I'm not belittling those people. I'm just saying that that can be the difference between experience and inexperience. So an experienced user will know exactly where to click, and literally there's phishing. I'm not phishing, but there's ads that lead you to the wrong download link, even on an official website. And that's just dynamics of the internet. So I'm going to show you how to download them properly and install them, and I'll give you a rough explanation of why you need each app or why you'd want each app. So if you don't have an unzipping tool, there is one built into Windows 10 now. I find 7-zip is still better. I prefer using 7-zip. But as an example, if I just go to my troubleshooting section, I've got a few zip files here. Now, zip files are archives. It means that they've been compressed into a single file to save space when downloading, and when you unzip them, they get slightly larger. And usually that'll be the case with portable applications. That a portable application is something you can unzip and run out of the folder. So I can go into the CPU-Z folder and run it, and it'll just work in that folder. So just here as an example, if I start that up, it's just running out of the folder. And if I want to uninstall this app, instead of going to start and looking for the program and uninstalling it, I literally just have to delete the folder. So you can see here as well, if I'm using Windows, the built-in Windows one, for example, I can click Extract All, that is Windows 10, and it'll give me an option of where to extract it, which folder, and you can see the UI. It is a little bit clunkier, but you can use it if you don't want to install an unzipping program. If I use 7-zip, it does this. 7-zip, extract to that folder, or extract here. Now, extract here will put it into the same folder, and extract to its own folder will just put it into the same folder with the same name as the zip file. So as an example, extract to, and that's done, and that's in its own folder now, and I can delete the zip file. So that's a quick explanation on how, archive files and unzipping works, and yeah, and why I would use 7-zip. So you can also do the same thing as Windows. You can go to extract files, and you can hunt for the path and put it exactly where you want it. You click these dots and look for where it is on your computer. And that's basically what the built-in Windows 10 one does, the same kind of UI as WinRAR and all that, which also gives the same kind of shortcuts, but I find 7-zip is just a smaller footprint. Anyway, they all work the same. So you want to get these files, and to download them, just search in Google, and the top link, CPU ID, is for CPU-Z. For HWmonitor, it's also from CPU ID, and for RealBench, which is a stress test program, RealBench 2.0, it's rog.asus. So this is another good practice tip for users that don't want to end up with malware and viruses, is whenever you're downloading something, make sure the URL is legit. And usually if it's a program that you know the name of, the top few results will be safe. So, rog.asus, which is Republic of Gamers .asus, and Asus is the motherboard manufacturer, and TechSpot is also a legitimate website, and you learn these things over time. Major Geeks is good, and then as the further down you go, the more sketchy things can become. It could just be a random website that's uploaded the file, and it could be malicious. So anyway, the top one's safe. HCIMemtest is for testing your RAM within Windows, so you can actually use your computer at the same time. That's why I prefer it, because you're not locked out of your system. If you want to run a built-in diagnostic and you don't want to download this, you can run Windows Memory Diagnostic, which is built into Windows 10, but you won't be able to use your system, and it can sometimes take a couple hours. So you'd want to make sure you have something to do, and you can leave and come back. And then if it finds a problem and you've got to tweak your RAM in the BIOS and try to get it stable, then you have to run it all over again. While with HCIMemtest, it will also find problems, but you can literally just browse or watch YouTube while testing your memory. So I find that a lot better. So, you can just go to download here, and you would search this in, HCIMemtest. HCI Design is the link. So download. And then you want Memtest Helper, which is GitHub Integral FX. Just type Memtest Helper and click that. Go to Releases on the right-hand side. And it's this zip file here. So I've already downloaded these just so that I can demonstrate how to do it all. And then Unigine Heaven. This is an installer. You can either, if you don't have a torrent program, just click Windows. That'll download it through the browser. If you do have a torrent program, or you want me to recommend one, I use BitComet myself. and that can sometimes download a bit faster. But in this day and age, most download speeds are fairly decent, so it doesn't matter which one you use. Um, I've tried both, and they both work fine. So Heaven is a GPU benchmark. I know it's not as intensive as some benchmarks, but the reason I like to use it is because it won't lock up your system if there is instability. It might crash itself, but it tends to be less of a hard crash compared to using 3D Mark or um, other stress test programs that tend to sometimes they can even overheat the graphics card when there's an underlying temperature issue. So FIRMark, for example, will heat your GPU up a lot more when you can already diagnose that there's a problem running something much lighter like Heaven, and it's free, and you don't have to go through Steam or something to download it. So grab all these, and I've already got Heaven installed, so I'm not going to re-download that larger download. But you can see in here where I've got everything: 7-zip, MemTest, extract to MemTest. MemTest helper 2, you want to drag into the MemTest folder after extracting. So, right click and extract MemTest to its own folder, then drag MemTest helper 2 into there. And I'll explain why we use MemTest helper 2 in a minute. And then, delete the zip files after you've extracted them. And go into the MemTest folder, right click, and instead of extract to, you go extract here. So it goes into the same folder. And then you can delete it. And then RealBench, which is the benchmark, and also extract to its own folder. It's a little bit bigger. Okay, so we've got all that ready. And then what am I going over? And then BIOS and drivers. So even though we've downloaded some stress test programs, I'm not going to go straight into using those stress test programs because I've got to explain to you all the things you need to check beforehand. Because if you stress test and your BIOS is like way out of date or your drivers are missing, your stress tests are likely going to show up low scores or come up with errors. So you can literally have errors from missing chipset drivers. You can have sluggish performance and all kinds of things. And as well from the BIOS, especially on newer CPUs, you can end up with instability. So you need to double check all that first. So for BIOS and drivers, you want to check your BIOS version. So go into CPU-Z, and if you've installed it onto your system using the installer, like if I show you over here with CPU-Z, when you click on the link, if you don't know where to click, there's setup for the installer, and that's an exe that you'll run. It'll install it into your system so that you have it in your start menu. When you search CPU-Z, it'll come up like that. If you want to get rid of it, it's actually fairly simple these days to uninstall programs because it'll come up with an uninstall button there, or you can right-click it and go to uninstall. So it's almost the same as unzipping the archive and having its own folder. It just, you don't have to go into a folder. It just puts it in your start menu. So it doesn't matter. They're both the same, and you want either of these top two ones unless you're Chinese and you want Chinese, whatever. And hardware monitor is the same. You have the zip or the setup, and then RealBench is a portable, so that's obviously we've unzipped that already, and MemTest is in its own folder. But either way, run them, run CPU-Z, and the important thing, and I know there's going to be some users that going from way back like me too, is we used to use DxDiag, which is built into Windows to get certain details. But the problem with DxDiag, I'll just show you right now. This is a problem in 2021 when you're kind of going by the book and you're using something like this. You can get your BIOS version 2.C2, but it doesn't tell you the AGESA version, which is important with Ryzen. With Intel, it's not as big a deal, but with Ryzen, it's important. You need the AGESA version because sometimes they change the BIOS naming where you can't actually find which BIOS you're on and you have to guess. And the only way you can guess is using the AGESA version because they do note that in most support pages for motherboard support, driver downloads. So that's part of the reason. And the other reason is if you're looking for your motherboard model, MS7B89 might look like a motherboard model that you can rely on, but when you search MS, this is just one good example, 789. Now, this is my board. It's a B450M Mortar Max. The top result is a B450M Mortar. So if I open up these two, you'll find they're slightly different. They're different boards. And the Mortar Max has a different BIOS. It's got a different size of BIOS. I don't know if there's a chance that they could be backwards compatible. Like the Max might be able to accept the non-Max BIOS, but I'm fairly sure the non-Max, which has a smaller BIOS chip, cannot accept the Max BIOSes because it's got larger CPU support. That's the whole reason they upgrade to the Max. But just for that example, if you search using DxDiag, you're actually going to get anything with this model name in it, and you can end up at the wrong website. So, it's got the same 7B89 system model name. So that's why you want to go through CPU-Z, and you get your manufacturer, which will be Asus, ASRock, MicroStar International is MSI. This is it for if you're not a builder. If you're a builder, you'll already know your motherboard, details. But if you're not a builder, the main important part is the model name. So for like Asus, it'll be B460A Prime or something, and all of those names are usually unique. So there's not a B450M Mortar Max from another brand, or even Mortar. There's none. It's only from MSI. So that's why you're a lot safer going by the model number than by the model name, rather than the model number of MS7B89, which is shared between two different models. So that's where it's important. And then looking at the BIOS version, we've got the date, which is not shown here, and then we've got the 2.C2 AGESA 1.100. So when I go to my Mortar Max support page, because this is why it's important, because we're using this to make sure our BIOS isn't too out of date. Now, what I mean by too out of date is you can have a BIOS that's a few versions old and it's perfectly fine, and you can have a BIOS that's one version old and a recent update has something important in it that you might need, especially on a brand new chipset. Like if you've upgraded to Ryzen 5000, that would be applicable, where a BIOS update would be much more important than an older B450 BIOS update if you're sticking to an older CPU. So when I go to the Mortar Max page, support, and this where I'm going to do it for two different models, just so that the Intel users are not going to think, well, this is useless. I can't use this advice. Asus Prime B460MA. So this is how you do it when looking up your BIOS. You get your BIOS in CPU-Z, and then you go to your BIOS section, which is under support, and you can see how they look really similar. Even different brands have very similar driver sections. So driver and utility, enter your, actually here it's got BIOS and firmware, sorry, and then it's got this section here, and here for BIOS in MSI, it looks like this on their website. Now you can see beta. Technically you'd want to avoid those because you don't want to be in a beta unless you're adventurous. And then it'll have all the different versions and dates. And it looks like, according to this, which is the date of the BIOS is 12/10/2020. So I'm not down at 16.6. I'm somewhere in between version 2.8 and 2B. But I'm on 2C2, which should be AGESA 1.2. So this is a little bit complicating, see. But basically what I can deduct is I'm not on 2B because it's got 2C in it, and the date is newer. So I'm somewhere in between these two. It might have been an early revision of the BIOS that they put on their OEM, like selling the motherboard. So it's preloaded on the motherboard, but the official release for download would be this one. So I'm somewhere in between these two. But more importantly, what you need to look for is compatibilities and updates that might be important. So if I update my driver from this one to this newer one or to the top one, I'm going to get I don't want the top because it's beta. Beta means testing. So if I go for 2C, I think I'll be slightly ahead this one because the AGESA is updated, and that's to do with the motherboard and CPU optimization, basically, for lack of a better term, optimization. But mainly, it looks like these updates are to do with resizable bar on NVIDIA graphics cards and 5000 series processors, both of which I'm not running. So, and then improved AM4 processor compatibility is also for Ryzen 5000 series processor. So being on Ryzen 3000, I can deduct that I don't need to update my BIOS. But if it said something like this, if it said improved boot up time, improved PCIe device compatibility, and I'm running like NVMe drives and things like that, or expansion cards, or improved memory compatibility, and my RAM was like not running, when I tried to set it up, it wasn't running XMP properly. All these are reasons you might want to update your BIOS if you're having instability especially. So later on in this guide, if you do run a benchmark and find, or stress test and find your RAM is unstable, and you remember looking at your BIOS and thinking, I don't need to update it, if there was a memory compatibility update and you're on an older version and there's a newer one, then you can just jump to the latest usually. The latest that isn't a test, like not a beta. So you jump to the latest one. So if I was on Intel, show all and check for anything that mentions compatibility, performance, stability. type of fixes. So if you're on a newer CPU, obviously you'd want to check for compatibility to make sure that it's running as optimal as possible. So sometimes it's unnecessary. It just really depends. So resizable bar support on a new RTX 30 card and you're on an Intel platform, that would be a reason to update if you're on an older BIOS. So that's how you check that. And then as for drivers, this is one area that can confuse some people. The important ones, the most important driver is your chipset driver when it comes to your motherboard. So here on AMD, it's just got the one link, AMD chipset driver. You can check the version. And with AMD, because they all follow the AM4 platform, there's not so many platform changes as with Intel. You're pretty safe going to the AMD website, or you might be better off going to the AMD website, search for AMD drivers, and they've got AM4 or chipset drivers for your motherboard here. If you go to chipsets, search AM4, this is for most consumer boards, and put in your chipset model. I'm on B450, and go to submit. And you might find that the revision number is, where is it? Sorry. I don't have my revision number here, but looking at I've got the latest one installed, but looking at the one on the motherboard side is a bit out of date. So 23.2.21 and 4.2.4.21 or 4.2. So, but the version number, yeah, you can see that it's newer on directly from AMD. So you might want to grab that. It's not too much of a big deal. Unless if you're on 5000 series, I would tend to lean towards AMD. If you're on an older platform, you've just built like a Ryzen 3000 build, you're probably fine just going from your manufacturer page, but either one will do the job. When it comes to Intel, I find Intel's not so picky. Their platform's a bit more matured, well, most of them, but you can just download whatever's the latest chipset driver. But the way that they have theirs laid out is they've got a ME driver and just a chipset standalone driver. And the ME driver is for management engine, and they call it consumer management engine, which is really, it's meant for mass deployment tools for administrators. Now, I'm kind of like simplifying that, but basically, at least on Skylake 6th Gen, it wasn't important. Even though they had a ME driver, I was able to just install the chipset driver that's only 5 MB. And that's the important one that actually says chipset driver. So that's a mistake that some people make, is that they'll download and install the massive driver, and they only needed the 5 MB one because the massive driver for management engine is what comes up by default as the top result. But it's up to you. I think they'll both do the job just fine. I think on like 10th gen, the management engine driver might be a bit more important. But in my experience, as long as the chipset driver is not missing, the system should still be fine for gaming. So it's up to you which one you want to use. The management engine does or should contain the chipset driver though. But I wouldn't want to bet money on it because I haven't been on a newer Intel platform for a while. So if you want to be 100% sure, it won't hurt to install both. Try to install the chipset driver first, and then install the management engine driver over it. And if the management engine has newer chipset driver contained within it, it'll just install over the top and update it anyway. So that's what I would do. And then your internet driver, this just makes sure your LAN adapter is working properly. It can help with performance and disconnection issues. And it's good to just update it rather than relying on Windows updates. And finally, your audio, which is Realtek audio. And usually the top one's fine. Yeah, they're all Realtek audio. And VGA would only really be important if you're planning to run your integrated graphics, or if you're on Ryzen, if you're running a G model processor, which is the integrated graphics models like 3200G, 3400G, 2400G. They're the ones that you'd want to go to the VGA drivers and download those. But otherwise, it's basically the same thing across AMD and Intel. Is you want your chipset, you want your onboard audio usually, unless you're running an external card. And it'll actually tell you have to be a bit careful with this. It'll tell you which version of Windows you should be running. So RS3 is Redstone 3 and then RS2. So the way you find that out is you can just simply Google Windows 10 RS3. Like, that simple. You can find the information you need if you just take a look. So RS3, and I don't know which one this is. This is a little bit confusing. Fourth major update, you'll have to do a bit of reading. This is normal. But to find out what you're on, go to Start and type WinVer. And you can kind of get an idea. So WinVer is build 19042.928. So looking here, I'm well past these releases of RS3. So when I look at the Intel AMD website that has, it says RS3 or later. So not RS2. RS2 would be even older. So if you're running an old build of Windows, that's a good reason to keep your Windows up to date, is so that you can not have any driver issues installing the latest drivers. So that's also how you check your Windows version. I recommend you try to keep it up to date. You can find incompatibility and performance issues running really old builds. So if you're running much older than 20H2, you can update it, and you can tell how old it is by looking at the build version. If you're running like 16,000 here, 160 something, then you know you're on a really old build, and you can update it. And to download an up-to-date Windows and create the installer, just go to, this is a bit off track, but if you want to update it, you can just type Windows 10 ISO. This is legitimate. This is not like pirating or anything. There's a Microsoft result that pops up, and this tells you how to make a Windows installer. And so you can either update to the latest version of Windows here manually, click Update Now, or if you have an 8GB USB, you can create an installer to reinstall Windows with a much newer build. And you can download that to a USB. It'll create a tool that'll let you install off a USB stick. And it'll download the full version of Windows, all legitimate. You might have to input your key in or buy a key online, buy a Windows 10 key. But for the most part, this is the safest way to get a copy of Windows without worrying about malware and tampered versions. So that's how I would do it. And once your BIOS and drivers are up to date, you also want your GPU drivers. So for AMD or NVIDIA, you go to the relevant website, type in AMD drivers or NVIDIA drivers, and then it'll kind of like have a self-explanatory. You can go to graphics here, and it'll tell you your graphics card model. Don't worry about the brand, because the GPU drivers, for example, AMD, even if I'm on Gigabyte, Asus, or whatever brand manufacturer, I can just get the AMD RX 6700 XT drivers and they'll work. Same with NVIDIA usually. 99% of the time, you can just go straight to NVIDIA and get their drivers, unless you're running some kind of weird hybrid graphics laptop. That's where you might want to go to your laptop website and download from there. But I think Windows do have I can't remember what they're called, Megatron something or rather. I can't remember how they named it. They do have portable versions for M series notebooks on their website too. But for the most part, most users will be, just make sure you don't accidentally click notebooks. You'll be on 30 series, 20 series, or maybe 10 series, 16 series, and you can find your model like that. You just put in Windows 10 64-bit game ready. Studio is for content creation if you want a little bit more stability, but I find game ready was always fun when I used to run NVIDIA. And for AMD, it's basically the same thing. You can go to graphics, select your series, and find your model like that, and submit, and it'll come up with a installer. So the top one. So that's how you do it. And in case anyone was wondering, do not rely on automatic driver software. It can work, but it can also cause disastrous results. So you could end up with a completely unstable system where the drivers are just messed up from using an automatic driver wizard. That doesn't go for all driver wizards. Some are fine, but it can happen where you'll end up with the wrong chipset drivers, and they cause low performance or buggy performance in one particular game, and you can't figure out what the problem was, and you reformat Windows and reinstall your drivers again, and someone will recommend get them from the Motherboard website, and then everything works fine. And that's actually happened before with friends, where they've used driver wizard software without really asking anyone, is this stuff safe or is this stuff good to use? With driver wizard software, sometimes you just end up with, kind of like when I searched the model number in DirectX Diagnostic, you can actually end up with the wrong drivers from a different series of motherboard which has really similar naming. So be aware of that. And then we'll go to Windows Update. So this is fairly straightforward. Just type Windows Update and make sure you don't have pending updates while you're doing this stuff. Because if you've got pending updates like I do, I'm not actually troubleshooting right now, but you want to make sure they're not just sitting there, because you can actually have performance issues from a pending update. And that sounds dumb, but it literally, if I get what's it called? There's a type of update that will literally cause lower performance if it's pending. I don't know if Windows does like some pre-optimization that can cause these issues. If I go to Programs and Features, where are they? See redistributables, and the other one is, I don't know if it'll come up here actually, under updates. Yeah, I think it's Visual C is one of them, and there's another type of update. It might be hidden. Net Framework, that's the one. So if Net Framework updates are pending, along with Visual C, they can cause weird issues with performance and even just like closing windows. I don't know if it's just my system, but I've encountered it more than once, where after I've run the update, everything started running fine again. So it was just like slight instabilities where, there'll be a delay when I'm opening my browser, and I'm like, why is this acting weird? And my system's like rock stable. I'm recording with ReLive right now, and it's coming through perfectly. But it was because of a pending update. So, download and install those, make sure they're all out of the way. If you do install an update and get issues, or if you're weary of updates, always like highlight it, copy the KB number, and search if there's an update. There was if there's issues, because there was a recent update through Microsoft, through Windows updates, that actually lowered gaming performance with VSync on. And so Windows update, just give an example here. 4 days ago, there was an update that lowered your frame rate when running VSync, and it tells you the models, and you can actually go back and view optional updates. Not optional, sorry. You can actually go to your update history and find if you've actually got this update that causes problems. But they did push through a fix for it. So even though Microsoft can sometimes release buggy updates, they will fix it with a future update that rolls it back. And they can even roll updates back silently where the user doesn't even know it's been rolled back. So just to be aware of that, I think it was 842 that was removed from my system, like it just disappeared. So anyway, that's one more trick that you should know about. And then we'll get on to the Windows optimization, which I can go into more into depth, but I think I might make it a specific video, like a dedicated video for that. But basically, I'll close this. With Windows optimization, you just want to make sure you've disabled some of the features that aren't necessary. So I'll just click Game. Type Game, go to Game Mode Settings. And Game Mode, if you're on a really high-end system and you're doing this optimization guide, you can turn it off. But if you're not sure about optimization and you haven't disabled any services and you're kind of like still in the new stage, leave it on. Because what it does is it disables certain Windows services when gaming to improve performance and latency. But on an already optimized system, it kind of does nothing, or sometimes it can even hurt performance, but it's a bit hit and miss. So it doesn't really matter one way or the other. Even me, I'll just turn it on. And if I have an issue in a particular game, I might check it. So it's one of those settings where, okay, I'm having an issue, I'm just going to try disabling it, see if it makes a difference. Something to be aware of. But I think they've improved it enough to the point where in early stages, in early Windows versions, it was causing issues in some games, and most of those issues should be ironed out by now. Now, the one for optimization, some of these settings are enabled by default. You want to disable the game bar, which is for recording, and go through your driver software for recording. Go through AMD, Radeon ReLive or GeForce Experience for your recording, and just avoid using all this stuff. It can cause performance issues. And yeah, so game bar disabled. And I think because I've disabled it, I don't have to worry about disabling the shortcuts. And that's all I'm going to go through. There are services you can disable. They're not a big deal. There's telemetry like Microsoft tracking that you can disable, which is kind of like nice for peace of mind, but not that important. It's not going to hurt your performance severely unless you're running a really old system. And you can actually just search, what's it called? I think it's called Spy Beacon. There's a nice app called Spybot Anti-Beacon, which disables a lot of telemetry, and it's automated. So just an example, I don't know about this website link, Spybot Anti-Beacon. Is that the actual website? I had a copy of it. I'm not going to, actually, no, I don't want to direct users and then someone goes and downloads it and ends up with something wrong. Informer, did these guys take over Spybot Anti-Beacon? I'm going to make sure that's the right link. Safer networking. See how that other website was like dodgy as? That's why I was hesitant. I was like, I don't recognize that as an actual website, even though it's using the name of the application. Informer.com is not what I know as the developer of Anti-Beacon. It's safernetworking.org. So anyway, there you go. That's one thing. It's one of those things you have to pick up over time. But spy bot Anti-Beacon, go to the website. There's a paid version and a free version. The paid version is slightly better featured, but you can just use the portable installer or the free version, sorry. If I can just find the download for it. They might have made it paid only. No, they shouldn't have. Wait. I'll click download and just see what happens. So I'm going to go for the portable installer. And I think it'll just be limited. So you can unlock it with paid, but you don't need to. And it's annoying because they're not showing the proper URL links under portable. Where are the URL links, guys? I guess just go by the date, 502. So the bottom one. Now I'll show you how this works. It's pretty cool. So again, if you're getting bored of this, or you're just like the video's dragging on for too long, just skip ahead so that you can jump to what you need. But if you're interested in this, just then hang around. So show in folder. So this is also how you can use. I'm using Brave browser, but it should be the same across most browsers. And then run that. It should unzip actually when I run this. Next, and it wants to go into the same folder. Yeah, so you can just run it, and it'll just put its own folder into the folder that you ran it in. So finish. You can see I've got a SpyBot Anti-Beacon folder, and now some people, if you're not aware of this application, it's pretty cool. So run Anti-Beacon loader portable. It'll check for telemetry that hasn't been blocked, and you can see how it needs some for Anti-Beacon Plus. I'm on the free version, but basically you can click customize and take a look at all the stuff it does, and it disables OneDrive. It disables all these unnecessary little things. Customer experience improvement program, telemetry, a lot of telemetry and stuff that you just basically don't need. And it checks for other things too, like pre-installed manufacturer, but this needs Plus. But luckily they're not found on my system. Google Analytics, and yeah, you can, if you want to use them, you permit it, lock it. Whoops, that was going to link me to an ad. Won't let me turn it back. Wait, it's trying to sell it to me. It used to be a little bit less pushy with that kind of stuff. But you can see most of it's not found on the system, and yeah, you can just hit apply, and it'll go through and disable the majority of that. There's a few that still need Anti-Beacon Plus, but if I can find, this is Anti-Beacon Plus, some of them, but for the most part, the Windows-based ones are all available through the non-paid version. So you can see there's a lot of stuff here that you don't need. If you use, Wi-Fi hotspot sense stuff, permit those. But it's a nice little app. And yeah, there's not too much else I can go over that's that important. It's mostly just the troubleshooting we've got to get through. So stability testing. Now, I'm just going to delete that because you don't need to keep it on your system after using it. Enter recycle bin. And we'll get to, my throat hurts. We'll get through to the troubleshooting side. So, we've already checked all the other stuff. Now, here's a list, just so you can see here, just read through this. Things that can cause low performance, stability issues, high temperatures, missing drivers, out-of-date BIOS, background processes, which we've already been over all this, system configuration. So if you've misconfigured your RAM, you've got it in the wrong slots. Ideally, on a brand new build, it'll be in slots 2 and 4 with a 1-stick gap, unless it's a micro, like a smaller form factor motherboard. Some of them only have 2 RAM slots, and if it's got 2 RAM slots, then it'll be in dual channel by default. But if it's got 4 RAM slots, there's usually a 1-stick gap in between. So your RAM should be in slots 1 and 3 or 2 and 4. So that, and then the wiring stuff. So as you can see here, I've just written those down, but I'm going to go through the process of how you would test. So after you've gone through all this, you've made sure your Windows is up to date, your BIOS is good, your drivers are good. That's when you can safely do stress testing that isn't going to be affected by these problems. Unless you have corruption caused by instability, which will corrupt everything, and your drivers will also be corrupt from that. But the problem is it's kind of hard to test for that without installing the correct drivers and running your stress tests. So if you're running overclocked or if you're a pre-overclocked system, you might have to Google and read a guide on how to set things to stock if you think you might have instability, because running things at stock is the best way to check for issues, and then you re-enable your overclocks later. But anyway, don't need that anymore. So first step for troubleshooting is we're going to do the memory. Now, the reason we do the memory is because if the RAM is unstable, your CPU benchmarks will be failing, and your GPU won't behave, because GPU testing will also crash. So you want to install, you have MemTest, we did this earlier. Now, the reason we get MemTest Helper 2 is because MemTest by itself, the free version from the MemTest website, if I run it, I'll just give you an example. If you want to run your memory stress testing faster, you have to run multiple windows because each window represents one thread on your CPU. That's the limitation of the free version. So if I want to use my 8-core CPU, just as an example, and test across 8 threads, I would need to divide my free memory by 8 and then run 8 windows with 2000 each. So I'm not going to do that, but just as an example, 2000, and then I'd have to run it again and have 2 windows, and it has like a warning box, and you open 2 windows and put 2000 in each. And the way you know how much free memory you have while using Windows for testing is you press Control-Delete, go to Task Manager, and then go to Memory, and it'll have available. So I can test about 12 gig before running into caching conflicts with Windows, Windows caching for faster loading. And there are ways to clear that so you can have more memory tested, but generally, if you're using the system at the same time, testing the available memory with an intensive memory test will pick up instabilities pretty quickly. So you don't actually need to test 100% of your memory. You can test half, but because you're only testing half, run those tests to 200%. And if there's an issue with your RAM, it'll usually come up with an error with one of the windows that's open. Now, just as an example, I've got 12,500 MB, or it says gigabytes, but you convert it. So 12.5 gig is 12,500 megabytes. And that's the reason we have MemTest Helper. So MemTest Helper is that tool I told you to download. What it does is it automates the free version's windows. So you don't have to manually enter 8 windows. So we'll just run that. First you test, you get your free memory. So for me, it was 12,500. And then I have a 12-core CPU. If you're not sure how many cores, you can check in CPU-Z, or you can just press Control-Delete, go to Task Manager, and hopefully you know how many cores your CPU has. But go to Performance tab, CPU, and right-click it, and go to Change Graph to, and it'll default be overall utilization. And see how it says 6-core processor? That if it says how many cores at the top, that does not mean that's how many threads, because cores and threads are two different things. I'm not going to explain it too much, but down here where it says logical processors, that's how many threads you actually have. And if you want to see your threads working, you can switch it to logical processor. So basically I have 12 threads. I could run a MemTest on each thread, but I want to leave some headroom for browsing. Just say I want to watch YouTube, or I want to watch anime or something while I'm testing my memory. So we're going to use 10 threads. So here we'd put 10. So base this off your CPU, put in your amount, and then go to settings. And because this was made for an older version of MemTest and they stopped supporting MemTest Helper, it kind of crashes if you keep it running. So it's not going to be able to automatically stop at 200%. You'll have to manually do that, but it can get the test running. So it opens all the windows for you. So first hit center if you want your test to appear in the center of the screen. And then rows is how many rows. So if you've got a high core count CPU or a high thread CPU, and you're going to have like 18 threads, then you might want 2 or 3 rows so that it's not stretching it out across the whole screen. But if you've got like only 8 threads or 10 threads like me, 2 rows is good. So I want it in the center of the screen, hit center, and that'll just automate where they appear. And I'm just going to run it so you can see exactly how it works. So I put in my free memory, and it's going to divide all of those across 10 threads for me. So start, and then hit, after it started them all, then minimize, and you'll see it on the desktop if I hit show. And then this thing will probably crash in a minute or two because it's not really, it's not supported anymore. But just to get the test running, these tests are running as if I had manually enabled them all. and they're running in sync. So if you have instability in your RAM, you'll have an error come up really quick. Even one error is instability, and you have to turn it all off and get back to square one when it comes to configuring your RAM and maybe adjusting your BIOS settings. If your system's unstable, just look up guides on how to configure RAM in the BIOS, or play with the RAM voltage in the BIOS, adjust things. But you have to basically look up a RAM overclocking guide and learn how to troubleshoot RAM in the BIOS to get it stable. If it's in XMP, you can just disable XMP and run it stock. And if stock speed RAM, it should run stable. And if you set it to stock and try to run this test again, and it still comes up with errors, that could be a sign of faulty RAM. In which case you would then run a dedicated test like Windows Memory Diagnostic just to cross-reference. And if Memory Diagnostic finds an error as well running at stock with XMP disabled, then you can be fairly certain there's a problem with the RAM. And you could try reinstalling it, make sure it's not seated poorly. So turn off your system, take the RAM out, put it back in, and or blow on it a bit. You can blow in the slots, make sure there's no dust in the slots. You can use an eraser to wipe on the contacts to make sure the contacts aren't dirty. That's kind of like an extra troubleshooting tip, but then you've got to clean it carefully and put it back in. And sometimes that'll help with an instability issue that's coming up with errors. It was just poor contacts and dust in the slot. Other times it won't make a difference, and that means you've got to take it back to the manufacturer and RMA it and return it under warranty. So that's just a rough explanation. But otherwise, yeah, you can run MemTest Helper, have your RAM test running, and start browsing YouTube or something. And as long as you've left enough spare resources, you won't get severe lag while doing so. So that's the benefit of that. And you want to go to about 200%. So do something distracting for a while. Don't game though. You can't game. That would be a bit too intensive. But just light browsing and watching videos is fine. And then when it reaches 200%, if they all pass, then just manually hit stop on all of them, and your RAM is stable. And then you then go into CPU and GPU testing. And then if you've had your XMP disabled, keep your RAM at stock, test your CPU and GPU, and then after those are stable with your RAM at stock, that's when you re-enable XMP, and then test your RAM again. So it can be a bit full on, like you're spending a whole day testing, but this is to make sure you don't end up with an issue that keeps annoying you for a whole year until you get to the bottom of it. So this will iron it out. So, run it stock and do all that, and then retest with XMP, and then if XMP is coming up with errors, that's when you might need to bump your DRAM voltage or adjust something else. Adjust the timing, or help. It could be a temperature issue, because at higher speeds, RAM can actually be unstable from a few degrees temp. So at 50C, RAM might throw up an error, but at 42C, it doesn't. But that's more to do with tighter timings and RAM overclocking. But for XMP too, XMP is technically overclocking RAM, because RAM is not made to. It doesn't run at that speed by default. It's actually overclocked by the manufacturers that are selling it with the XMP rating. So it's been tested on their systems to run at that speed. But it doesn't always mean your system will be able to do it, because it's to do with the motherboard and the CPU memory controller as well. So, and there's nothing you can really do. If your memory controller is weak on your CPU, it's basically bad luck. And you can only try increasing voltages. That can sometimes help compensate for a weak memory controller, but other times you'll find there's a ceiling where you just can't run a certain speed, past a certain speed with your particular CPU. And the only way to really get around that is by either changing your CPU or sometimes upgrading to a higher quality motherboard. Can help with compatibility, because it's a sub-timing or something else that just won't run with your memory controller. So anyway, enough of that explanation. After you've tested your memory, move on to Asus RealBench, which I found is the closest to a real-world stress test for the standard user. So what I mean by that is when you run more intensive stress tests like IDA64, Prime 95, OCCT, or Intel burn test, a lot of those place an unrealistic computational workload, which is more meant for folding at home or scientific calculations and diagnostic type of things, where you don't really need that as a consumer. Maybe you're going to do some rendering, some 3D graphic work, and some heavy multitasking. And that's what RealBench simulates. So when I actually tested in RealBench and tested my system stable, I did it for just 30 minutes. My temperature reached a certain amount, and then when I went and did some real life rendering later in the week, I hit exactly the same amount that RealBench was showing me. While I've used other stress tests before, like Intel burn test, where I'm actually getting 20°C higher temps, and in real world usage, including rendering, I never ever hit that kind of temperature. So it's kind of like not necessary. So RealBench just works like this. You can also use your system while running it. Just don't do anything too heavy. And there's a stress test setting. You can set it to amount of runs, but ideally you want to run it for 30 minutes. So just wait for it to gather system information, and then go to stress test, just left click it, set it to 30 minutes. We've already tested our memory, so you do not need to use a large amount of memory, because you might also want to multitask. Maybe if you've got 16 gig of RAM, run 8. That's usually fine, and then click start. And you can actually watch it do its multitasking and all the things that it tests. As you can see, it's running like Luxmark in the back. The way it tests is very natural for what might be a multitasking workload for someone that's doing productivity work. So it's still more intensive than a gaming workload usually would be. Although gaming does load the CPU to a fair amount. But this is a good way to test your CPU without overly stressing it. And one thing I forgot to tell you is that while you're running RealBench, go back to your other folder where we downloaded stuff, troubleshooting, and run HWmonitor and while you're running RealBench, because this is another reason we use RealBench, because it's not so heavy a load that you can't run a good monitoring tool and get accurate readings. And basically all you want to look out for is your CPU. So you can find it, just close. See, the top one's your motherboard, second one's my CPU. You'll find your CPU because you should know the name by now. And you just want to look at your CPU package or temperature, and the value is the current value, and then the max is the rightmost column. And if you're up at 90°C, you either have a really hot room, or you've got a poor cooler mount, or some other temperature issue to do with the mounting of the CPU or the fans or the case airflow. And if you're up at 90°C, I would recommend you stop the benchmark and address that first. So either improve your airflow, check that the cooler is mounted properly, make sure you remove the sticker from the underneath of the CPU cooler. If you didn't know, some of them have protective film on the bottom, and you don't want to stick it onto the thermal paste with that protective film still attached. And get your temps ideally under 80°C. 80°C would be like my limit, and maybe 83°C for a short period is fine. But if you're going to be doing long rendering, you want to upgrade your cooling or address that cooling issue first. So what I would call a good temp is under 70. Getting hot is 80, and too hot is 90 plus. Even 80 can be considered too hot for a lot of people. Like, oh, that's a bit abnormal. But again, if you're on a stock cooler, it can also be normal, especially if you're in a tropical country. And another thing you can do is you can go into your BIOS and find there's a fan section where you can actually set a more aggressive fan curve to get those temps down. Even if it's like 100% at 70°C, and if it keeps it under 70 and it's noisy, then that's why you might want to upgrade your cooler. But just something to be aware of. So run your test 30 minutes, and hopefully it passes. If it doesn't pass, I'm going to bring up the window here. Sorry. When it passes, I'll just show you. You're going to click stop to cancel it. Click stop, but it'll say result hash match when it's running stable. And if it comes up with an error, it'll literally come up with, in red text in this blank area, it'll say error. And that means that your CPU is not stable, and you have to either improve the cooling. So here we go, result hash match. You have to improve the cooling or address your CPU in the BIOS. Like, they might actually need a BIOS update if it's a really new model CPU, or there could be an issue with, hopefully not with your CPU itself if you've done a pre-built or a custom build, and one of the pins might be bent on the motherboard or on the CPU, depending on Intel or AMD. And you'd have to actually check that, but usually it's something to do with configuration. So if you're running it stock, it might be simply a matter of improving your temps and maybe bumping the vCore in the BIOS a little bit. That can get things stable. Or it could be, well, we already tested RAM. RAM would have failed if it was the RAM. It could be a motherboard issue as well if your CPU is failing stress test, or an airflow issue if your motherboard is overheating it somewhere else, and the CPU temps look fine, but you've got like one case fan at the back and no intake. That could be a sign of a temperature-related stability issue. But otherwise, it'll come up result hash match, and you just let it run for 30 minutes, and then you're good. You're good to go after that in terms of CPU. So I'm just going to halt that. And lastly, we'll get to the GPU stress testing. Again, it's to do with the temperatures and the fan profiles that you want to be aware of. So we'll keep this open, and this time we're going to be staring at the GPU at the bottom. Now, if you're running a newer model like I am, there's actually another important temperature that won't come up in HWmonitor, and you have to learn to use hardware info, which is a bit more daunting because it's got so many more readings to filter through. So you can Google it. Hardware info is the name. I'll just quickly show for the new users that are still scared of downloading things. Hardware info is the URL, and just download the portable or the installer. It doesn't matter. It is not this button here in orange. That's for Landsweeper. It's an ad, and so that's a browsing practice that you need to be careful of. It's actually this green button here that expands. So any of these is fine. So you download the portable. And hardware info, you run it with sensors only. Sometimes it'll have that unchecked, summary only. Click sensors only and click run. And the reason it's daunting and I didn't want to recommend it off the bat is because by default, I've actually got my text enlarged because it makes it nice and easy to read. But by default, it has so many parameters to filter through, and it can be overwhelming. You want to slide down and just look at the headings, and you can just minimize them like this, kind of like how HWmonitor does it. But because there's so many more, it can just be that little bit more overwhelming for a new user. Minimize everything and find your GPU, which will be at the bottom usually. And when you find your GPU, it does say GPU, so you won't get you can't mix it up. And then the important one is your hotspot temperature. And look at the maximum column. That's the most important column when it comes to diagnosing issues. And I won't bother explaining voltages, but the hotspot temperature and then the memory junction temperature, which is your VRAM or graphics card memory. So separate to your system RAM, your DDR4 or whatever it is, your graphics card, your GPU has its own memory built into it that can overheat. And for GDDR6, it is 100C T-junction. This is a T-junction sensor, which is in the middle of the chip, like in the center of the chip, basically. And it's the same as the hotspot temperature for the GPU core. So the GPU core hotspot, the GPU hotspot temperature is for the core of the GPU. It's actually in relation to this normal GPU temperature. So the normal GPU temperature is actually the edge of the GPU die, which is kind of like the processor of the GPU. And the hotspot temperature is the center of the GPU die, or the hottest point on the GPU die. So the memory is not this, like I've actually seen some people say, oh, well, the hotspot's not that hot, so my memory is fine. The hotspot is completely different. It's on the GPU core, and the memory is the GDDR6 chips themselves. And if you're on GDDR6X, then obviously there's different, it's made slightly differently, but when it comes to the physical and material manufacturing, it's the same as GDDR6. The voltage tolerances are the same. And it's just the way that the way that the signaling works inside GDDR6 is like overclocked GDDR6X is like overclocked GDDR6 in a way. For lack of a better way to explain it, it is GDDR6 on boost. So it gets really hot, and the thermal junction, according to Micron thermal data sheets linked on the GDDR6X product pages, is 100C. And so if you're running at 100C or over when doing stress tests or whatever use case you might be using your GPU for, disable that test and get your temps down or set an aggressive fan curve. And that is basically all I'm going to say on that. So anyway, for a basic user to just try to find any issues, have this open. Make sure you can see the max column. And I'm not actually on an ultra-wide monitor, but I'm doing this video in 1080p so that smaller monitor users don't see microscopic text. That's why I've got everything blown up, so that users that are not running on ultra-wide can actually read everything I'm putting up on the screen. So for me, this looks massive. And on a 1080p monitor, it'll probably look even larger, but at least you can read it. So now that we've got this open, we can see our GPU details. That's when you start up your Heaven benchmark that you've installed. It'll pop up like this. And the standard, this is also good for performance diagnostic because you can compare your score. It'll give you a score at the end of the benchmark to other users to see if something's wrong. Now, for testing that your system is working, depending on your resolution size, if you're on a 1440p or higher monitor, just run the test in windowed 1920 by 1080. That way you can see you're monitoring at the same time. If not, just run it. If you're on a 1080p monitor, just run it in 1080p in full screen and Alt Tab out while you're at the menu to test as an initial test if there's a severe temperature issue. So if you're having stability, GPU stability problems, gaming stability problems, your games are black screening, Windows is just going black, you're losing monitor signal, those are all classic symptoms of a GPU temperature issue. Sometimes it's a driver crashing issue, but usually the drivers crash when the GPU is unstable because of temperatures. So to check that, run it, and I'll just do it live so that you can see exactly what I mean. This is how you would test. You don't actually have to run the benchmark to get an initial idea if you're getting a temperature issue. So I'm at the main screen, hitting enter changes the scenes. You can see the FPS is very high. So this is already putting a 99% load on the GPU. Alt tab out and take a look at the hotspot temperature. If you don't have a hotspot reading, just look at the GPU temperature, the rightmost one, and as you can see, they got fairly high. And then it also shows you what utilization you reached as maximum. So it did hit 99% from when I turned this on. And that is enough to see if there's a temperature problem. You don't actually have to run the benchmark. This is just a precursor. The benchmark puts even more load on the GPU, but this can help for users that have a poor cooler mounting. They bought a secondhand GPU that had the thermal paste incorrectly applied. They took their PC to a technician, and then the technician refurbished the GPU, and they put too much. They did something badly. You can diagnose that if any of these temps are over about 80C, just running at the main menu of heaven, then that can be a good sign that you've got a temperature issue. You don't even need to run the benchmark. I would fix the temps. So for hotspot, I would say 90C is already pushing it, and you might want to try to get your hotspot temps down. And for memory junction, obviously 0 to 95C is the operating range given by the manufacturer of the memory. So 0 to 95C, if you're running at 95C in the heaven menu, then yeah, you might want to address that. One way you can address it is through your drivers. Other than having to pull your GPU apart and change the paste and worry about pads, make sure your case has got good airflow. And then in the drivers for NVIDIA, GeForce, or for AMD, there's a section for fan control. I can't show you the NVIDIA one right now. Let's wait. See if I can get the Radeon software to open. And it's under, for AMD, it's under performance, but it'll be similar for both brands of GPU. And sorry, the drivers, because I'm recording at the same time, the drivers are being a bit finicky. I've got like 3 things running. I want to go to performance tuning. And as you can see here, the default looks like this. And it's just on an automatic curve. And the automatic curve spins up very slowly. It lets the GPU get fairly warm before it'll start. And if you're in a tropical country or you've got case airflow issues, just setting a manual curve can be enough to alleviate some of those symptoms. So you can just hit enabled and go to advanced control, find your fan curve section, and you can just set a curve. Like this is my gaming curve that's fairly quiet at Windows, but when I start gaming, it ramps up very aggressively to keep the temps under 70C. Up to 90C is fine. You can run up to 90C on hotspot, but ideally lower is better. So, 80C is around default for the peak temperatures of most fan curves, and I put mine at an aggressive 70C because I'm not fussed about the fans getting worn out. You can replace fans for very cheap compared to the cost of replacing the GPU itself. So that's my reasoning behind it. So you can basically set an aggressive curve, hit apply, and then you can save a profile. And you save it. There's usually a save profile button, and as you can see, I've got a few different profiles. This gets a bit more intermediate, but just for your fan profile, you can just name it fan profile and don't change anything else, and then you'll have a nice, more aggressive fan curve like I've set up. And that might be enough to fix your temperature issues. Then go back into heaven and see if sitting at the menu is getting the same temperatures. And if your temperatures improve, maybe you can run the benchmark. If you're under 70C or under 80C, then you can try running the benchmark, but you might even want to go into windowed mode and run it side by side depending on how large your monitor is, because that will give you a little bit more of a live reading of your temperature. Because it's a bit harder to alt-tab out when you're in the middle of the benchmark. So if I run the benchmark like this, as you can see, it's running. And if I alt-tab out, oh no, it still lets me. You can see that the GPU utilization dropped, though, on current. So current is the actual reading when I alt-tabbed out, and it's kind of jumping around a bit more, 81.0. So my benchmark's going to be ruined. That's not usable anymore. But kind of pauses it actually. But you can also check if you're worried about a temperature issue. Don't bother completing the benchmark. If you're diagnosing temperatures, just run it for like, it says scene, like run it to scene 6 or 5, and then alt tab out at scene 5 and see if your temperatures are good, like they're holding stable around 70 or 80. And then if they're not climbing over that, if they're not climbing towards 90, or I think 80 would be my limit personally, depending on, if you can optimize it more, you can optimize it. But if you want to play on the safe side and keep temps lower, I would set 80 as a limit. And then if they're not pushing above that, then you can run your full benchmark. And the benefit at the end is run the full benchmark, don't alt tab out, check your max at the end to make sure it's not pushing too high. And with an aggressive curve for most people without any airflow issues, that should be enough. And when you get to the end of the benchmark, you'll get a score, and you can use that score as a comparison against other users without the CPU being so much of an issue. In certain other more intensive benchmarks, the CPU can actually affect the score too much to be relevant as a comparison that your GPU is running normally. So in Heaven, it's actually less CPU intensive, that you can actually go, okay, my score is getting, at 1080p Ultra Extreme, which is one of the more common settings people use, my score is matching up with other 3070 users. So that's where it's useful to run Heaven, because it's a well-known benchmark that anyone can download and it's free. So yeah, and if if you're running 3D Mark, you can't. It's a lot more clunky. Like if you want to alt tab out, check temperatures, good luck. I don't even know if it'll run in window mode. So that's how I do it. Ultra Extreme, check your temperatures, make sure that's all good. And at the end of all of that troubleshooting, especially one of the more common ones is the background processes. That would have been the first one that fixed problems for a lot of people. At the end of it, you might be able to run, if you've passed everything, you could go back to that game that's having issues and see if it's still doing it. And there are game-specific fixes that you might need to incorporate. And if you're still having issues with your game, just comment down below and I will try to help you diagnose it. And I'll already know that you've been through most of this, and hopefully that helps you guys out. And that's the end of the video. I might do other videos in the future to do with BIOS configuration and overclocking and undervolting, but for the most part, I just wanted to share this because a lot of people don't know all these little tricks. So thanks for watching, guys, and if that helps you, please like and subscribe, and I'll see you in the next video. Bye.